Well, hello, M126 fans. Continuing on, somebody's asking me about this question, so let's do another little error-bound game. They're just asking about the last part, but we might as well see it. This is kind of unusual because this is actually already a polynomial. So what this is doing is it's basically recentering the polynomial at 1 and making it a smaller degree. So it's kind of an unusual use of Taylor polynomials, but that doesn't really change anything. We just need to set up our clothesline. Here it is. Here it is. And then we need to hang up our derivative values. So there we go. We need 3 things to compute. F of 1, which is 1 plus 1 plus 1 plus 3, so it's 6. There goes the 6 there. We take the next derivative. It's going to be 1 plus 2x plus 9x squared. We plug in a 1. It's 1 plus 2 plus 9. It's 12. Let me know if I make a typo here. I'm just trying to get to the next part. 2 plus 18x. We plug in a 1. We get a 20. Well, that wasn't so bad. Okay, the next part says find the error bound, find an interval around B such that the error is small enough. So let's compute first the third derivative, which is 18. So keep in your mind that the third derivative is 18. All right, determine an interval around B such that the error is smaller than this. So whoever wrote this question was trying to keep the third derivative as simple as possible. The third derivative is 18. So we have to come up with a number that's greater than or equal to 18. I think I'll use 50. I'm joking. I'll choose 18. 50 would be okay, but I'm going to use 18. 18 is the tightest bound we can get for 18. Now I'm going to fill in the rest. So the interesting thing about this is we did not know the beginning and ending of the interval. And so what we do in these questions is we call this 1, and then we start to walk away. So we walk over here, we walk over here, and we would like to know how far away we can walk so that our error is smaller than this. Well, let's label that A and minus A. So that was that idea of, okay, let's have the interval be 1 minus A and 1 plus A. And that's what we're searching for. The question actually doesn't say it has to be symmetric. It just says you have to have an interval where the error is less than 0.024. Okay. I should have said that already, but ultimately this did not affect this at all. So now we need to finish filling in Taylor's inequality. So we say this is less than or equal to m over 3 factorial x minus 1 to the 3. So the question we're trying to figure out is what is the biggest thing we can put in here so that this is going to be smaller than 0.024. And actually the question does not say, there's a key word here, it says you can give any answer that works. So there's sort of an optimal answer that Taylor's inequality gives, or you can give something smaller. Okay, so let's finish it. So now we're going to put the m in there. So we have 18 over 3 factorial is 6. And then we don't know what x is, but we know the biggest it can be is 1 plus a. But that's nice because the 1's cancel, and so we get a cubed. And so we want, let's state what we want. We want, that's going to be 3. 3a cubed needs to be less than this. Since the question says this word an instead of the or the best, you can pick any number that works here. But let's just solve it. I think whoever wrote the solutions was trying to be clever. So let's do 0.02. I don't know if I have my calculator sitting out here. Darn it, I usually do. Well, shoot. I'm going to grab it here quickly. Okay, got it. So we're going to do 0.024 divided by 3. And what I got was that a cubed has to be less than 0.08. I don't know why I put that in my calculator. I'm getting loopy. I've been answering questions for too long. Divided by... So now we're going to do the cube root. Again, why did I put that in my calculator? So a has to be less than 0.2. I don't know why I looked for a calculator. That was a huge waste of time. Okay, anything that's smaller than this would be acceptable to make the error strictly less. Honestly, if somebody said 0.2, I would also give them full credit. But the interval needs to be something smaller than the following: 0.8 to 1.2. So I would accept that. I would also accept 0.9 to 1.1. I would also accept 0.997 to 1.12, which isn't even symmetric. You just have to have both the numbers within 0.2 based off of this little description. All right, I hope that answers your question.